Now let's discuss the main vulnerabilities of DNS. First of all, we must be able to trust the domain name and address mapping provided by DNS. In fact, many security policies depend on this. For example, the same origin policy in browsers, or URL-based filtering. Obviously, if the host address mapping provided by DNS can be forged, then the traffic intended for the original legitimate host is now destined to the wrong or malicious host. This means that the wrong or forged host can now intercept the legitimate traffic. What if the host address mapping provided by DNS can be forged? For example, instead of getting the IP address of gmail.com, the browser instead gets the IP address of evil.com. The result is that traffic will be routed to evil.com instead, which means evil.com can intercept traffic to gmail.com. There are several ways to forge the host address mapping. For example, the attackers can compromise the DNS servers, including cache poisoning that we're going to discuss shortly. Or the attackers can control the access point or gateway and intercept DNS queries and forge a response. A solution is to authenticate each request and response using cryptography, and DNSSEC is such a solution. Now let's discuss attacks on DNS server, in particular cache poisoning. The basic idea is that the attacker would provide to the local DNS servers some false records and get the records cached. For example, if the local DNS server queries the domain gmail.com and the attacker is able to inject a response with the IP address of evil.com and have that IP address of evil.com cached by the local DNS server, then subsequent traffic to gmail.com will be routed to evil.com. The existing defense in DNS is to use a 16-bit request ID to link a response with the query. That is, the attacker's response must have the ID that matches the ID of the original query. And we will discuss how an attacker can overcome this defense. A DNS cache can be easily poisoned if the DNS server does not use the IDs properly or the IDs are predictable.